This video covers the ALEKS topic, graphing a linear inequality in the plane with a vertical or a horizontal line. So a linear inequality in two variables can be written as a form ax plus by is less than c, less than or equal to, greater than or equal to c, where a, b, c are real numbers and a and b are both not zero. Like a linear equation, but instead of an equal sign, they have a greater than, less than, greater than or equal to, or less than or equal to sign. So for example, here we have our linear equation, y is 3 halves x plus 3. Here we have our linear inequality. So the line, because it's less than or equal to, is still part of our solution, but we also have to shade all possible ordered pairs that make this inequality a true statement. So each ordered pair is said to satisfy the inequality, and every ordered pair is a solution. So there can be infinitely many solutions to linear inequalities. So we know the graph of a linear equation, a line, is all the points that satisfy the equation. Similarly, the graph of a linear inequality in two variables is a set of all points, and that's going to end up being the line if it's less than or equal to or greater than or equal to, or it won't be the line, and then you'd have to do a dash line for less than or greater than, and then you have to shade one half of the plane. It'd be either greater than or less than. So let's talk through that. So how do I graph a line? So first thing you want to do is replace your inequality symbol with a linear symbol, with an equality sign, and graph the corresponding linear equation. You're going to draw a solid line if it was less than or equal to or greater than or equal to, because that means the line is part of the solution. You're going to draw a dashed line if the linear inequality had a less than or a greater than symbol, because then the line is not part of our solution. Once you've done that, you want to choose a test point in one half plane. You cannot choose a point on the line, and you substitute the test points into the inequality. I always pick the origin if I can, because it makes for some nice, easy math. If a true statement results when you substitute in that ordered pair, you shade the half plane containing the test point. If a false statement results, you shade the half that doesn't contain the test point, because that means that that point was not in your solution. We're going to do 3 examples, and I want to give you a quick note real quick that if y is greater than mx plus b, you shade above, and if it's less than, you shade below the line. But sometimes it's kind of like hard to tell like what's above and what's below the line. So I always recommend the test point method just for clarity. And to check yourself. You always want to check your work, especially on exams and quizzes and things like that. So let's do a few examples. I have x is greater than 6. Okay, so this line is going to be a vertical line because we go to 1, 2, 3, 4, 5, 6. So here's where x is 6, and I'm going to use a solid line because it is included in my solution. Then I need to decide whether to shade to the left or to the right. Well, I'm sure you know from our work, if I'm saying x is greater than 6, you're like, okay, Dr. Miller, we're definitely shading the right-hand side over here, but I want us to pick a test point. So let's pick a test point. My test point, I always like to label it. You don't have to. My test point, whenever I can, I pick the origin. So I have 0, because that's my x, is greater or equal to 6. That's false. That's false. So that means where the test point is not part of my solution. So I'd actually want to shade to the right. So we can shade over here. Let's do another example. Next I have x is less than -3. So I go to -3, and because it's less than and not less than or equal to, that means -3 is not part of my solution. So I'm going to do a dashed line. Well, less than 3, I think we'd know we'd want to shade to the left, but let's do a test point just in case. My test point 0, 0. I have 0 is less than -3 because that's my x. This is false, right? So that means that this point right here is not in my solution. So I would go ahead and shade to the left. And this is kind of clearer to see when it comes to vertical and horizontal lines, but when we start working in linear inequalities in 2 variables, you're gonna see how it might be a little not so clear. Our last example is when y is greater than 4. So here's where y is 4. It's greater than, so not greater than or equal to, so I'm going to use a dashed line. And because it's greater than, I know we're going to want to shade above, but let's pick a test point just to be careful. So my test point is 0, 0. So I have y is 0. 0 is greater than 4. That's false. So because it's false, I know that this test point isn't in my solution. So I'm going to go ahead and shade above.